all fair. Okay, now we're live.
Yeah,
Cool.
there we go. My name is Kenzie Dodds. Hi there. And
Hi.
I'm here with Bonfrey.
Yeah,
We're going to talk about SnapCI and continuous integration and deployment. So, yeah. I've been trying SnapCI a little bit. So where I work, we're using Jenkins, and I don't really like Jenkins all that much. It's just a lot to manage yourself, and I would just rather, or I'd just as soon as offload that to somebody else. And so, and especially like I'm a front-end engineer, and so my build stuff is like wildly simpler than like all the other like back-end stuff.
Yeah.
And so, so for me, Jenkins is just way too much weight. And what we're doing right now is for the front end is we're doing some stuff that is similar to what the back end is doing. Like I run my build and it outputs to a directory. Then we make an RPM out of that directory and upload it to a repository where ultimately it gets yum installed and deployed out to a server somewhere. And like most of that stuff, I'm just like, I have no idea. I know how to npm run build, and then like it's whatever. So for me, I've got a bunch of open source projects, and I've tried Travis CI. That's what I've been using for a long time, actually. And then I figured Travis CI probably wouldn't do it for what we needed, and so I wanted to try out a couple others, and I tried CodeShip. I really liked CodeShip. I tried Circle CI. I like them. And I tried SnapCI, and I like Snap. So I'm just trying to decide what would be best for what we need. And every one of these services I've had highly recommended by more than one person. So, and I also tried Worker.
Right. Oh yeah,
Worker was cool. I really liked their interface. It was really slick. But it didn't just work like other services have, and so I prefer.
To be fair, I think they're still in beta.
Yeah. Okay.
Yeah, I think technically they're still in beta. So, but yeah, that is definitely another interesting entrant into the market.
Yeah. So, can you tell me like what are some of the things that differentiate you against other people in the market?
Sure. I mean, I guess the way we see ourselves as being different is to give some context. So Snap is built by ThoughtWorks, right? ThoughtWorks is a global consulting company. We also have a product division. A lot of people know about ThoughtWorks because of either the work that we've done, or people have run into a lot of speakers and authors that we have who work for us. So you might have heard of people like Neil Ford, Martin Fowler, Jez Humble, Dave Farley. These are all people that have worked at ThoughtWorks and published a lot of their work. That's where people get to know of us. And really where we come from is the background of having built and delivered software for over 20 years for customers ranging from tiny startups all the way to Fortune 500 customers, right? So we've seen what it takes to get software out the door over and over again. And in fact, that's really where some of the ideas that led to the continuous delivery book being written actually came from. They are from projects that we actually implemented at ThoughtWorks. So we kind of in the crowd over here, we kind of have a deep knowledge and insight into a lot of it, even tacit knowledge of what it takes to actually do continuous delivery, which has unfortunately been conflated with this other term called continuous deployment, with which it's not really related at all, but really what we specialize in.
Curious for you to talk about that a little bit when you get time.
You mean the differences between continuous delivery and continuous deployment?
Yeah, so I hear continuous delivery, continuous deployment, continuous integration. So I generally just say continuous delivery and deployment.
Yeah, so I think those all those three are actually very, very different terms, and I think we would not, like I personally would not conflate any one of those terms with the other. I think continuous integration has got, all three of these terms have got very, very specific definitions. Continuous integration is everybody on the team commits multiple times to master. There is a suite of tests, an automated suite of tests which are expressed in code, which can be run anytime there is a change to the code base. And on any change that everybody does, all the tests are run, and the tests now tell you whether your code base is healthy or not, whether the application is functioning the way it was supposed to or not. These tests can be designed in any kind of way. They can be top-down, bottom-up, they can be system-wide, they can be unit, they can be driven through test-driven development, they could be written after the fact, it doesn't matter. So the requirements for doing continuous integration are, you need a version control system, you need a team that's checking into that version control system on a regular basis, ideally multiple times a day. You need to have what is called a self-testing code base, which means the code base is capable of testing itself and answering the question, are you healthy or not? And then at the point where each person commits to the master, and everybody checks into master, and as each person checks into the master of the version control system, the tests run, and they tell you whether the application is healthy or not from a code perspective.
Just on master, or does that apply to other branches as well?
Well, ideally, people would do trunk-based development, and trunk-based development means people do not sit around with code on their own branches, because that actually makes a lot of things really complicated. And in fact, some people go to the extent of saying branching in general does not work with continuous integration. Like doing feature branches is against the idea of continuous integration. I would soften that a little bit, but I would still say that sticking to branches and working extensively with branches is probably not a healthy thing. I think
that's really interesting to me.
Yeah, I think the primary goal of continuous integration is to prevent unforeseen problems from happening when large quantities of code get merged with each other. So the fact is, if everybody's sitting on their own feature branch, it's a long-lived feature branch. So I will just clarify what my position on that is. I think long-lived feature branches are actually inimical to doing continuous integration, because if everybody's sitting around with large chunks of code on their own branch, there's absolutely no saying what's going to happen when you attempt to merge it. So you may technically be running Jenkins, but that doesn't really mean anything, because continuous integration is less about whether you have a tool doing it or not. It's whether you have the practice of making sure that everybody's code is integrated and tested, and you know whether the application is healthy. The tool helps, but really it's the discipline of doing that on a regular basis that's more important. So that's continuous integration.
Okay, right? So you would say that it's, from a continuous integration standpoint, it's okay to have a short-lived branch that just has a couple of, handful of files that are changed, and you do a pull request, you do a review, and then you merge that in, and that's just fine.
Well, yes, I would say that it's caveated with what is the size of the change that you're doing, that you're pushing through. If the goal of continuous integration is to keep the size of things that you are doing, the goal of it is to make sure that small amounts of work from individual team members can all be integrated more easily than large chunks of work that appear once every 3 days. So whatever you do in order to make small chunks of work happen over each other, as long as you try to do that, you're going to be much better off than trying to merge large pieces of functionality. Cool. There are many benefits to that too. So
what about continuous deployment then? What's
so continuous deployment is that's interesting, because what it is exactly what the code term says. I mean, you take your code every time you make a change to the repository, you take your code and you deploy it somewhere. Right. I think in and of itself, it's not particularly interesting, and I think a lot of times it is a red herring, because it speaks to the interest in getting code deployed, but the problem with it is that it is divorced from getting your code deployed is not the problem. Anybody can get code deployed, right? The point is, are you trying to get high quality, valuable software deployed in a reliable manner on a regular basis? It's all these other qualities that surround the act of deployment that is actually more important. The act of deployment itself, all that it means is somebody who knows how to automate a deployment process and has gotten it done. Now, that's good. I'm glad we have that. And having that is better than not having that. But it is certainly not a substitute for doing continuous delivery. And in fact, a lot of people do it only because you can take your continuous integration loop and add a step right at the end of it saying, when your tests are done, deploy it. So it's an easy way to jerry-rig your CI server into doing a deployment for you. So continuous deployment can be done as a very trivial incremental step on top of any sort of CI loop that you have got going. So it has gotten popular, but I would say that continuous deployment has got very little to do with continuous delivery by itself. It can certainly be a component of it, in the same way that continuous integration is a component of doing continuous delivery. Continuous deployment may be a component of doing continuous delivery, but it is not necessary. It's certainly not a requirement in order to do continuous delivery effectively.
Okay, yeah, that makes sense. And so continuous delivery then, how does that differ from continuous integration?
So continuous delivery is a much bigger scope. So continuous delivery is a way of delivering software. So in fact, why don't I just pull up the perfect definition, the definition that Jez himself gives. Funnily enough, it's not in the book, but he does mention it in a conversation with Martin Fowler. And what he says is, the essence of my philosophy to software delivery is to build software so that it is in a state where it could be put into production. We call this continuous delivery because we are continuously running a deployment pipeline that tests if the software is in a state to be delivered. Right, and that is basically continuous delivery. So it's a philosophy and it's a way of building software. And at its core, it includes continuous integration, because one of the key aspects of knowing whether your software is ready to be deployed is knowing whether it does the things that it's supposed to do. And tests help in establishing that. But then there's a lot more, because your software can not just have functional requirements. It may have cross-functional requirements. You may need to do a round of, I don't know, slush testing, memory testing, perf testing of any number of sorts. You may want to deploy it into a QA environment, and you may want to have a bunch of people look at it. You may want to do a bunch of usability. You may want to deploy it to a usability testing environment and have your UX people try to do some usability tests with that software. And finally, you may want to write documentation, release notes, and then deploy it through to production. So there's a lot of activity involved, not to mention all the automatic configuring of the machines and provisioning of the machines to do the deployment. There's a lot of work involved, which is beyond just the core of, is the code written in order to get your software delivered out. Continuous delivery is the process of taking all of that into account and bringing that all into a sort of mechanism that allows you to deliver software on a regular basis with all these additional characteristics added on top of just, do I have code that does one thing?
Yeah, okay, that is very clear. Thank you very much. I'm going to be sharing this on Twitter all the time, because this is really useful information. So now I'm curious more about specifically how SnapCI accomplishes this. One thing that I noticed that's different about SnapCI than any of the other CI services is the pipelines, and how each item or each stage in the pipeline is totally in complete isolation from the other stages, which I think is very smart and very interesting. And for what I do, it's not entirely necessary because my stuff is pretty simple, but I could see how that could be wildly valuable for more complex builds.
Sure. And yeah, so the idea of a deployment pipeline is actually central to doing continuous delivery at all. In fact, it is, I believe, it's chapter 5 of the continuous delivery book, talks about how the deployment pipeline lies at the heart of all the automation that continuous delivery is about. And the point of a deployment pipeline is it essentially functions as a visual representation of the value stream map of your software. So effectively, all the way from conceptualization to the point where it actually reaches the hands of your customers, software goes through a life cycle, so it goes through a journey. Every step of that journey gives you, as you get closer and closer to production, hopefully what you're doing over the course of taking your software through that process or through the deployment pipeline is getting more confidence as it progresses through the pipeline that it is closer to being ready for production, right? Having the software work with unit tests is one thing. Knowing that the software actually can be brought up, launched, and that it integrates with other components That's the second thing. The third thing is knowing whether it stays up and continues to serve the requirements of people after a particular amount of time and has all the cross-functional characteristics that you want. Finally, does it actually meet the usability characteristics that you want? And lastly, is it documented and can it be released into production? That entire sequence of steps, as you progress through each of those, there's a way to verify that characteristic in your software and to explicitly make that manifest to the whole team, not just to you, not just to one person, so that knowing whether the software, whether a particular change has been deployed to a staging environment or to a testing environment is not something you need to go and ask the ops person who was handed a binary yesterday. So the point of a deployment pipeline is by visualizing the entire value stream map of how your software goes all the way from development through to production. Everybody on the team, not just the development team members, but the developers, the testers, the designers, the project managers, the analysts, the ops people, everybody can see that one visual pipeline and have an idea of exactly where the software is at, whether it's green, whether it's red, and how far it is down the pipeline in getting into the hands of the users. Because at the end of the day, that's the only true measure of software. Has it gotten into the hands of users, and is it actually delivering value in production? So the pipeline gives you one way to visualize that entire thing for the team without having it be ad hoc conversations that people have to have with just the right person in order to know whether software was delivered to a particular environment or to a particular person.
Yeah, that's solid. I like that a lot. That resonates with me. Why don't I just ask or describe kind of, as I've been analyzing these different tools and kind of thinking about how I want to do things, I've developed a kind of a sort of a proposal, I guess, for how what our process will be like. And so I'd like to describe that to you, and then you can tell me if I have any flaws or holes in that.
Sure.
The plan is, right now we have 2-week sprints, 2 weeks of QA, then release. I think that's pretty common. I'm not a huge fan of it. But so I don't think that the 2-week sprints is going to go away very soon, and certainly not 2 weeks of QA. And so when I move things over to a new system, I want to make sure that everybody else's process is pretty much the same, and then we can slowly close the gap and get to continuous delivery. So, so my plan is that we create a branch called Q2, we'll say staging, and then another branch for production, and then master would be to our development environment. And so each of these branches would deploy to their own environment, and when we're ready to cut the release for the 2 weeks of QA, then we merge master into the staging branch, and then after that 2 weeks of QA, we merge staging into production. And then the deployment process would be the same, just deploy it to different environments. And then on top of that, we would have a branch. I don't know if folder is the correct term, but I think like it'd be for any of our features or bug fixes, it would be PR, like pull request / and then the name of the thing you're fixing. And based on what you said, I really like the idea of keeping those really small and short-lived as possible. So we make this branch, we develop, we push it, and we're going to hopefully move to GitHub, and so we'll use the GitHub pull request. And then I want SnapCI to build it and deploy it to an own temporary environment like an AWS bucket or something, so that QA and the reviewing developer can both certify that it's ready to go, and then it gets merged into master. So do you see any, and then ultimately, slowly the QA time goes down to a week, and then maybe we get rid of the staging altogether, and then it's just master and production. And then slowly we move to maybe a more Kanban style and continuous integration and deployment or delivery at that time. So do you see any holes in that kind of a process?
What you're describing is a fairly common process. The only thing I would potentially, I wouldn't say this is definitely going to be a problem, but I would be cautious about it. I am always very cautious about testing bug fixes in isolation, because bugs in essence are caused by interaction of one portion of the software with other parts of the software. So if you are going to have a bug fix that is tested in isolation and somebody verifies it saying, I took a completely clean slate and I applied only this one bug fix on top of that clean slate, and I was able to verify that this bug did not happen at that point in time, it is not particularly useful as long as you can guarantee that that is exactly what will get deployed into production as well.
Yeah, that's a good point. Yeah, I hadn't thought about that.
Yeah, I think that this is I can see the appeal of this idea because it's a very clear way of thinking about it, saying every time there's a pull request, I can see the exact change of that pull request. And I think a lot of it works in the more visual sense. Like if somebody had said, I want this button text to change from X to Y, you can literally log into your regular staging environment and into this bug fix environment, which has got only this bug fix applied on it. And you can see visually compare the differences or go through to user flows and verify that the user flows have actually changed. But I think that while that sort of there is that potential for clarity, I think it's a false sense of confidence that it gives you because it does not tell you what is going to happen once you actually merge it, and everybody else's code is going to go on top of that as well.
That's true.
I think, I think it gives a false sense of confidence, and I am always wary of anything that tells me that things are better than they are. I'd rather things actually warn me about things being worse than they are, because that actually makes me a little bit more cautious and makes me pay attention to the quality of the software. Whereas if I'm given a false green, then I start getting worried about things, because a false green just means you are waiting for something to actually explode in your face before you know it. And the whole point of doing continuous delivery is to not do this sort of reactionary waiting for a bug to explode in production and then scramble trying to find out what happened. It is to actually be methodical and disciplined in your processes. So I would personally, on any of my projects, I would not try to deploy a single bug fix to an environment that is isolated for just that one bug fix alone, despite the obvious attractiveness of that idea.
Yeah, So that's interesting. So I think the reason or part of the appeal is I don't want to push code into master to actually be deployed until I can verify that.
That is exactly.
But then I can't verify that it's totally integrated until I've actually integrated it.
Well, no, but that's exactly the point. Well, that's exactly why you need something like a deployment pipeline. So Snap has got deployment pipelines, and the interesting thing about that is you can check in a fix for anything that you want, and you can have manual gates in your deployment pipeline. So a deployment pipeline is not a completely automated series of things that runs from start to finish. If it were, then it wouldn't be any better than a monolithic build, really. So the point of a deployment pipeline is that each stage can be configured to do one thing at a time. So if you've got a QA or a testing environment that you want to deploy to, you can make your change, and your change will go all the way up to the testing gate, and the testing gate can be made manual so that somebody needs to explicitly deploy into the testing environment. And others can keep checking in on top of that if they want. So, and all your builds will stack up, and they will all wait at the testing gate. And you can actually go into the build history of Snap, and take any of those changes that you want and deploy it into your testing environment when you want to deploy it in, and test the functionality. And then subsequently, the production can be manually gated as well, so that you don't actually just deploy to production just because you ended up triggering a commit into a particular branch. I think this entire notion of you just check in a commit into a particular branch, and then every branch has got an automated target that it deploys to, is another thing that I find quite odd, because the whole point of continuous delivery is to make sure that changes that happen on one branch, the exact same changes get propagated through to every environment. Because the last thing that you want is somebody doing a merge, forgetting to merge one tiny bit of it, or the merge happening in a slightly different way than what the code actually looks like on master. And then all of a sudden you're deploying from master to environment A, and you think you're going to get exactly that same behavior as environment A after having merged the code from master into release. And you can't guarantee that, because you've taken a blob of code and you've put it onto another code base effectively, and now you're waiting for it to get deployed elsewhere. There's absolutely no guarantee that the behavior you saw in one environment is going to be the behavior you saw in another environment. So the ideal way to do this would be to do all trunk-based development, to use feature toggles to turn off what functionality you want on and off. And then you take all your code from the master through to every environment. And that's exactly what Snap gives you, is you can take an individual change set and the exact same change set. And if you're building RPMs or binaries, bit for bit, that exact same artifact that you generate in the first stage of your pipeline is the exact same artifact that you will deploy to staging. It's the exact same artifact that you will deploy to production. So you don't have this snowflake problem of, is it the same artifact? Did I rebuild it? Did I rebuild it slightly differently when I pushed it to the branch? All of those questions just go away. And that kind of has to go away, because you cannot afford to have those kind of vagaries in the process of building your software. So the idea behind using a deployment pipeline and this kind of automation is that you get full traceability and complete bit-for-bit artifact propagation, which says that the exact same artifact, the physical binary, you can even fingerprint the MD5 checksum on it, the exact same physical binary will get propagated through to every single environment. And so that is really the benefit you get. And by using feature toggles appropriately, rather than relying on really complex pull request, merge, and review mechanisms, you have much more fine-grained control. So you can deploy to staging with a manual gate if you want. And once it's deployed to staging, you go in, toggle the feature toggles that you want in your application, and verify the functionality. And if it's fine, you didn't need to hold the train. Nobody else needed to wait on you. People could keep building on top of you, and you can just go back into the pipeline that was created 10 pipelines ago and deploy that change into production anytime that you want.
And then you move on to the latest change or latest pipeline that's being held
and then you sequentially go up the pipelines, move up in the chronological order, deploy the next change set into staging, verify that, and push that into production. So it gives you a much more disciplined way of going about the process.
So let's say that I've got a pipeline that's gone through and it's waiting at staging, and then 3 other people go through and they have theirs, and so now I have 4 stacked on top of each other. Do you start at the bottom and you work your way to the top, or do you just start at the latest and test all of the ones and then
that is completely up to you and your team. So that's the kind of thing that we try not to be prescriptive about, because different teams will want different ways to work with it. So you could deploy the one right on top and then verify all the 4 fixes or all the 4 pieces of functionality. And in fact, that might be ideal depending on what you plan to actually deploy into production. But you're not stuck with that. If you find that the one right on top is not working as expected, you can actually go to the previous one, deploy that into your staging environment. And once that is deployed into staging, verify that at least that smaller portion of functionality is fine. And if that turns out to be fine, hey, today you can release 3, and tomorrow you can release the one that you plan to release. So let's assume that these 4 pipelines that you've got stacked on each other each have 1 feature, right? Simplifying just for the sake of an example. If you run the topmost one, you'll be deploying 4 features into production. But is it better to deploy 4 features that you can't verify, or deploy 3 that you can verify as working correctly today, and then deploy the 4th one tomorrow? Yeah. So that's the kind of benefit you get. You get to go back one and deploy that into staging. Your QA, whoever else wants to verify it, they can verify it, and then you can push those 3 into production without actually impacting anything before or after that.
Okay, so I think the one drawback that I see with not doing a pull request and verifying pull request is if somebody puts something in and it turns out that it's like wildly wrong, and then they leave or they get hit by a bus or something, then you have to go back and revert the commit. That's probably like not a bad solution, just revert the commit. Or you have to figure out how to backtrack on their stuff. Have you seen that ever being a real problem, or is it just as easy as revert the commit and start fresh? The problem that I could see is if I put something in that totally breaks everything, and then without noticing it, a bunch of other people put stuff on top of it that depend on maybe some abstraction that I built. Now all of a sudden we have like 7 features stacked on top of each other that depend on this stuff that is totally broken, and we can't deploy any of those until that one gets fixed. Is that really a problem, or is that just kind of the way that software is?
No, well, I mean, it can be a problem depending on the time gap between when you introduce the abstraction from the point where you introduce the abstraction into your change, to the point where that change was merged into the central code base, to the point where people started building on top of that abstraction. Now, if the time delay between all of these is days, and you still haven't deployed your fundamental abstraction hasn't still been tested or deployed into production, then yeah, we have a bit of a problem. I mean, and if that abstraction is completely wrong, then you have a problem. So the problem really is not one of people building on top of wrong abstractions. The problem really is one of how frequently do you deploy and how big are the deployment units that you make. So if you have, large quantities of changes, so you introduce an abstraction, it's faulty, and everybody builds towering edifices on top of that, there's no way you're going to be able to take that entire thing, whether you use pull requests or not, and then push it out into production. So if you're using pull requests, all that it means is people would have used some other abstraction that existed, because if your abstraction was essential for them to actually do their work, then either they would have waited and not built anything, or they would have used another flawed abstraction that was there in the code base, or probably built everything else more inefficiently. So there is really no way of...
You're no better off.
Yeah, you're not really any better off. You're taking that inefficiency and you're smearing it out in a different way. But essentially, the inefficiency of deploying large chunks of work is going to be something that takes its toll on the team, one way or the other. You can choose to do that in terms of something fragile going into production, bad abstractions going into production, people doing work more inefficiently. All of those things are consequences, but they are consequences of the fact that the unit of work that gets deployed is very large and not necessarily a primary artifact of the process. As much.
Okay, yeah, that makes a lot of sense. Yeah, I think you've really convinced me that SnapCI is the only CI service that can provide this kind of confidence. And yeah, because none of the other ones have this concept of staging and of stages and manual stages. And
Worker, incidentally, I think they're trying to do something similar, but that's why I said Worker is actually interesting to look at.
Yeah. Okay. Yeah. So I'm pretty sold on SnapCI. It's pretty awesome stuff. So, is there anything else that that you'd like to mention about Snap that I maybe don't know about, or anybody watching later might want to know?
Well, I mean, sure. I mean, we do have pipelines, and a particular pipeline structure is associated with a repository branch. But we also we understand that people create branches, but we encourage them to be short-lived branches so that people actually close them out as soon as possible. So what we try and do is it's slightly better than not doing anything at all for people who do feature branching. If you do a feature branch, Snap will automatically recognize it because GitHub informs us when a branch is created on a repository. We then create a build for that branch, and we automatically run the tests for that. So you don't have to set anything up.
Really? So any branch that I push to the repository?
Well, you get to configure what branch prefixes you want, but if you don't configure any branch prefixes, then Snap will build every branch that gets created.
That's cool. That's great.
Yeah, you can automatically, of course, that is a feature called automatic branch tracking, and you need to enable it. We don't enable it by default, but you get to do that. Once you have done that, we have the functionality to do what is called an integration pipeline. So a branch pipeline is basically something that will track the changes on that branch. In other words, as you keep making changes to that branch, the tracking pipeline will continue running and will actually test all your changes. In addition to that, we provide what is called an integration pipeline, which does something very similar to what a pull request does. So the pull request testing functionality in Snap and Travis and all the other tools does, which is we attempt to merge the change that you made on the branch with the master, or whatever you configure to be as the merge target. So we attempt to do a merge, and then we run the pipeline again.
Wow, that's awesome.
Yeah, so for every change that you make to the branch, you don't get one build result, you actually get two build results. The first build result says whether your own build is good. The second build result actually says whether you are in a good place to merge into master or not. If you find out that the change you're making on your branch cannot be merged into master, that should hopefully be a trigger for the developer to go in and fix it such that their code is in a state where it can be merged into master, and ideally also merged into master as soon as possible. You may want to continue working on that feature branch, that's fine, but we want to give people as much incentive and information as possible to merge that feature branch, the code on that feature branch, immediately into whatever the master branch might be, whether it's called master or something else. So we give people two pieces of information over there in order to do that more effectively. So that is one thing that we try doing. It's similar to what people do with pull requests, but but nobody does it for branches yet. So we do that for branches as well, so that you not only know the health of your own work, you also know the health of your work with respect to the master, and that gives you an incentive to check in more frequently into master.
Yeah, that's awesome. Man, I love that. Cool. I hope I can convince my coworkers that this is a good idea and we should move. I think I'll be able to, at least for my stuff, and then maybe for the back end stuff, they'll come along when they see how great it is.
Sure, cool. I mean, yeah, and if there's anything, if there's any way I can assist or help out or answer any more questions, you can reach me. You've got my email address. You can reach me. You've got me on Twitter as well. DM me, DM us. Our support team is, well, we don't have a separate support team. It's just the development team. So anything that you put into the talk to us button actually creates a support ticket. So we'll get back to you as soon as we can on those things. But yeah, feel free to reach out to us over any of these channels, and we'd be happy to answer any other questions that you might have.
All right. Sounds great. Thanks, Madhuri.
Yeah, great. Thanks, Ken. Bye-bye.
Bye.